Hi and welcome everybody. This is the UCCS Speaker Series. I'm Richard Kravitz, Director here at UC Center, Sacramento. As some of you know, this is the fifth segment in our ongoing series on artificial intelligence. So far we've covered the basics of AI, AI in education, AI in healthcare, and just last week, AI in government. But today our focus is on AI in the economy, and in particular, the economy right here in California. In the debate about how AI will affect economic life, there's basically two views. The pessimistic one is that AI will upend our economic system, eliminating many jobs now performed by humans and causing not just economic upheaval, but potentially social upheaval as well. But the more optimistic view is that just like the internal combustion engine and the internet, AI will create at least as many new jobs as it displaces, and that the new jobs maybe will involve less drudgery and be more likely to rely on our unique capacities as humans. I'm not sure which side today's speaker will come down on, but he's definitely qualified to address the question. Matthew Harding is Professor of Economics and Statistics at UC Irvine. In his academic work, he develops techniques at the intersection of machine learning and econometrics to generate insights from big data pertaining to such areas as health, energy, and consumer finance. He's particularly interested in the role of technology and automation to induce human behavior change and help individuals live happier, better, and more sustainable lives. Professor Harding earned his PhD from MIT and has previously taught at Oxford, Duke, and Stanford. He's published numerous articles and book chapters and is the recipient of many awards, including selection as a Data-Driven Innovation Fellow by the U.S. Chamber of Commerce, and he was runner-up as Economics Teacher of the Year at Stanford. Please join me in welcoming Professor Matthew Harding.
Thank you. Thanks for having me here. It's a pleasure, and I'm hoping to at least start the discussion around the impact of AI on the economy and so California's economy in particular. And this is I just want to acknowledge at the beginning, one of my fantastic graduate students, Nick Fucci, who really helped with the research for this presentation. So I think as we just heard a second ago, we are at this very interesting phase as far as the development of AI is concerned, because we see both the opportunities and also the risks. And I think on both sides of this debate, there are a lot of very good points that are being made, right? So yes, there's enormous potential here in terms of what we think AI can do for us and can deliver. But then it's also perhaps surprising that some of the people that have been involved in the development of AI for decades, people like Geoff Hinton, who's sort of considered like the one of the first people to really reintroduce AI into like the contemporary discussion and in terms of the newer algorithms, also see a lot of risk here. And I think and where we're going to go next in terms of balancing out the potential and the risk is something that we don't know yet, and I think that future still remains to be written. But I think what we are able to already start doing is at least have a bit of a framework in which we can understand and we can place some of this discussion, so it's not just like a pure guessing game. So what I'm going to try and hope is present an economist perspective on some of these issues in terms of how I think we can understand these questions. But really, I want you to leave here with the idea that nothing is yet inevitable. And we're in Sacramento, where policy is being made. It's certainly the case that policies are going to shape the future, and the rules and regulations around AI are going to shape the future path of innovation and how it's actually going to be implemented. So I would like to talk a little bit about where I think we are in terms of AI today, and in particular related to jobs, and see how do we really fit AI into like the current framework for work. And then we're going to take a step back and think about this technological transition that we are now at the very beginning of. What might be the impacts on the labor market, and also are the analogies with like past transitions useful to in this kind of context? I think it will be very hard for us to make predictions about AIs in the very distant future, because so much of that hasn't been written yet. But I think we have some sense of where we might be in the near future, which allows us at least to start the discussion about opportunities and costs, especially for California. So that's going to be the outline of my talk, and I'll take questions at the end. So where are we as far as AI is today? So I thought, what better person to ask about this than ChatGPT? Let's see if we agree with what AI is. And as always, when you ask an AI, you're going to get some surprising questions that you have to, surprising answers that you might want to question. So I'm not sure if point number 5, if AI fashion and product design is really what we all think about when we are thinking about AI. Certainly a lot of the excitement right now is around generative AI. And the one area that AI has really distinguished itself in the last couple of years is the ability to handle text, to handle language at a level that is unprecedented as far as existing older technologies around machine learning are concerned. So certainly when it comes to content generation, language, and images, AI is currently sort of has exceeded our expectations. But a lot of other areas where maybe it hasn't made as much of an impact as you might think. So in more traditional aspects of economics and finance, much of it isn't actually run by AI yet. So your investment portfolio, your pension isn't really managed by AI. Doesn't mean that it's done manually, but it relies a lot more on established statistical and machine learning approaches as opposed to the kind of technology that is behind ChatGPT. And there is a technical explanation for that. And that's because the current AIs are very good at handling discrete data. So text is discrete. They're words that are discrete. Pictures are discrete because they're pixels. The AI frontier that I think might potentially revolutionize the usability of these techniques comes in terms of, are we going to be able to process continuous things? So I can build a chatbot, but am I going to be able to build a model of a functioning human heart with all the kind of real-time continuous activity that actually happens, and the signals and the processes that, and we are not there yet. So when it comes to like the existing capabilities of AI and how we think about it in the context of work, let me kind of give you like my understanding of how work works. And this is a very stylized model. And I really think about completing a project or working as essentially combining a set of different tasks. Each one of us, when we're working on a project, we need to use different abilities and different skills in order to complete that project. So typically when I ask my students to complete the project, they're going to need some mathematical skills. So there will be some tasks that require them to use mathematics. And there will be some tasks that require them to like use language and being able to explain what they've done and write it in cohesive English. And different projects that you're going to be asked, whether as a student or in the workforce, are going to combine these different skills that we have. And different jobs consist of utilizing different bundles of skills that you have. So if we think about, I want to introduce a concept that's recently appeared in the managerial literature in a very recent paper by Harvard Business School, which is the idea of a frontier, right? If we think about the different tasks that humans are able to do, and also AIs are going to do. So I'm going to paraphrase a little bit the argument from their paper to make it more useful for us. We can think about these frontiers as essentially jagged. There's certain things that humans might be very good at. So humans might be very good at like doing basic math, while AIs are not very good at doing basic math. And so this frontier, I drew them like being sort of wavy because different projects that you might have, and think about them as different work, different aspects of work, some things are going to be very easy for humans to do, and they might be very difficult for AI to do. And the opposite might also be true. There could be certain things like translating very fast from one language to the other without looking things up in a dictionary. That is something that ChatGPT does very well, and the human would take them a lot more time to actually do it. So right now, I think this is the picture of where we are in terms of what it is that we can do best. There's certain things that humans can do best, there's certain things that AIs can do best, and these frontiers do not overlap. So I think the question going forward, and this is the way I really see the value of AI, so I'm going to call these the sort of AI-augmented human workers. I am personally a little bit less worried about AIs replacing humans entirely, and I see more the potential in AI augmenting our human abilities. So if we think about the way we process and assimilate knowledge, you go back 30 years ago, you had to remember an enormous amount of information from your textbooks in order to be competitive in the job market. Nowadays, it's okay if a lot of that information lives in Google and you just know how to access it when you need it, and that's really the kind of skill that you need. So I think where I think we are heading is essentially combining the human and the AI in order to achieve, hopefully, a better frontier in terms of this sort of augmented human frontier, because we're likely to rely more and more on AIs as a way of retrieving information and organizing information that is available to us. And I think this is sort of an important realization at the beginning of, if you went back 5 years ago, you would have heard people talk about how AIs are going to replace radiologists because AIs are so much better at this, looking at pictures and detecting skin cancer than humans are. But that's not actually what happened. In fact, employment for radiologists has increased. Why? Because you actually combine like the uniquely sort of like human element with like the AI element, and you're going to get humans that are actually more productive and they can do more. And of course, we've also realized, going back to this jagged frontier, that there are many parts of a radiologist's job that cannot be taken over by AI. The AI is not going to be able to communicate very well and very politely with the human. So a lot of what a radiologist is doing is not actually being replaced by AI. And that significantly changed the discourse. So where are we going next with this? I think the real question for me is, once this technology stabilizes, are we going to be in a point where we're going to see continued progress? So are we going to be able to push this frontier outwards further and further and further as AIs develop? Are we going to be able to perform more things and do them better than we are doing them now? And for me, that's, I think, the real technological progress that I would like to see. But there are also kind of a lot of questions here that I don't have the answer to, but I think we need to think about. Some of them are going to be very practical questions. We don't know what the limits of this technology are, because there's a lot of science that still needs to be discovered. We are nowhere near knowing the entire mathematical framework behind AI. There is a potential, of course, that some of the human contributions are going to be replaced, but there are also likely to be limits in terms of how we can use this technology. And some of those some of those limits might be limits that we're actually going to impose ourselves. And this is, I think, a very important point to remember. Policy does shape the future and the growth of a technology, because even though we might be at the early stages of regulating AI, there's no reason to believe that we are not going to see increasing regulation of AI, and that regulation is going to shape the development of this technology. And I'll come back to some of the potential and also some of the challenges a little bit later on. So let's think about technological transitions in general. Can we learn something about the future by looking at some of the past technological transitions that we've experienced? This is a difficult question in some way, right? Because it's very fundamental to how we do science. How much can we actually learn from history? And I'm sure some of you might disagree on many of these points. There are similar technologies, that at least we think are similar. So I don't know whether I would want to say let's predict the future by looking at the past, but I think it would also be a mistake to ignore what's happened in past transitions. And we have a lot of similar technologies that was certainly proved to be revolutionary, whether it's like moving from steam to electricity or the introduction of information technology over the last decades. So what might be some of the lessons learned from that? I think maybe the first lesson is things are going to take a lot of time. All of these technologies that we've seen in the past, even though the technology was available, it took a very long time for it to actually be implemented at scale and change the way we actually do things. Because it's never the case that you can just take a technology and plug it into an existing system, into an existing economy, and it's just going to replace whatever you're taking out and work better and work faster. There are numerous processes that have to be changed around it, and we don't know yet what those processes might be and how it's going to involve. So I think that's lesson number one. But I think lesson number two is every policy and every technological transition has seen a lot of distributional impact. And I think, especially from a policy perspective, I am always very concerned about the distributional impact of a change that we make. We need to go beyond just measuring and anticipating the mean impact of a change and really thinking about how it's going to impact the entire distribution. And any kind of technological change and any policy for that matter is going to have winners and losers. And I think it's important to kind of anticipate and be prepared for some of this. So let me just take a step back for a few minutes and talk about the integration of computing technology. This has now happened for decades. So we know that it's impacted people differently. In particular, as it's had a tremendous benefit for college graduates. They've benefited a lot from having access to IT technology, and their work has increased in productivity, which has certainly been reflected in wages. But it's been challenging for less educated workers, and that is responsible for the kind of what we call in economics the wage polarization that we've seen over the last few decades. So previously, as we've increased productivity, wages have increased so proportionally, both at the lower tail and the upper tail of the distribution. The more recent kind of technological change and the impact of IT has been uneven. So at the very low end of the income distribution, other things have happened in terms of the availability of government programs and policies. But really what we've seen is kind of the stagnation in the middle part of the distribution, coupled with like a higher rate of increase and a higher benefit at the top end of the distribution. And we don't know whether this is necessarily going to be replicated, and in fact, we actually think it might be a little bit different. I'll come back to this point. One of the things that we're learning right now is that perhaps the people who benefit most from the current developments in AI are actually the people that have somewhat lower skill. It's benefiting people with higher skill a little bit less than it's benefiting people with lower skill. So this might turn out to have a very different distributional impact than previous policies. But I think in terms of the dimensions that we need to be concerned about are around education. We've seen the impact in terms of task displacement, in terms of change of hourly wages, be very different across workers with different incomes, workers with different education levels. So I would say these are some of the variables that we need to continue to pay attention to in terms of how they're going to impact, how they're going to be impacted going forward. And at the same time, when I said it's hard to know whether like the past is necessarily a guide to the future, because we've all experienced this massive structural break, which is the economist's fancy word for saying the world has changed since COVID. It's very hard to really know to what extent the past is going to reflect the future, and we've already seen some of these trends that have been happening for decades are somewhat reversed or alleviated right now, and that partly this has to do with bigger macroeconomic aspects around. The labor market is very tight. We've actually seen different policies at the federal level and at the state level that have favored non-college workers. So some of these existing trends in wages might already be changing. So that makes this kind of prediction task quite challenging going forward. So what do we think is going to happen in the very near future? I think one should never trust an economist when they're making long-term forecasts. So I'm not going to attempt that. So I'm really going to focus on where we are right now. And in fact, in economics, we have two different words. We have forecasting and we have nowcasting. Nowcasting is when we're predicting today. We're predicting things in the very near future. So rather than forecasting, I want to do a little bit of nowcasting. One of the things that we're seeing, so here we see a bunch of different standardized tests, and the performance of blue is GPT-3, green is GPT-4. When it comes to standardized tests, we are seeing these AI models performing incredibly well. Why? Because a lot of these tests involve retrieval of information. The AI is very, very good at remembering things and having access to this entire range of material that we as humans are likely to forget. But with the newer AIs, and that's the green part, we're looking at sort of GPT-4, they are starting to also do better on things that we would consider more in the realm of logical reasoning. So not just retrieving information, but also combining it and drawing deductions from it. And I think the extent to which AIs are going to be able to expand in terms of the tasks that they complete and the skills they can replicate and perhaps outperform is going to be really key. We're at the very early stages of understanding this, and I want to show you some examples from different papers. In the interest of time, I'm not going to give you all the references, but they are on the slides, so please feel free to look them up. there are a number of different experiments that are being conducted in terms of adding AIs to the regular workflow and essentially seeing what happens, right? And I find this really key in terms of combining AIs with human skills. And what we see is that as we add AI to human tasks, a lot of the improvements that we're seeing come from say the bottom half of the participants. If we were to rank workers in terms of high-skilled worker, very good workers versus workers that might be struggling, we are seeing that the workers who might be struggling, once we give them an AI tool, they are starting to catch up. And in fact, their performance becomes nearly that of the high-performing workers. And nowadays, this evidence is a little bit limited because the technology that has mostly been rolled out in terms of AI in the workforce involves things like customer service, involves chatbots. So it hasn't penetrated like the entire range of skill sets that people have. And I'll say a little bit more about that in a second. But we are seeing this rightward shift in terms of AIs improving the productivity of workers. Interestingly enough, it doesn't seem to necessarily translate into higher customer satisfaction or, it's, in that sense, I don't know whether humans and AIs at this moment are necessarily pushing the frontier outwards and allowing us to do things differently than we're doing them up to now, but it's certainly helping some of the lower skilled workers catch up. And this is interesting in terms of the impact on workers because we tend to think that skill and tenure in particular in a job have a big advantage in terms of your performance and your productivity. And one of the things that AIs seem to be giving us is they're leveling out the field, and so workers with less experience are now able to perform as well as workers with more experience. But we're certainly not seeing in these early experiments that people are doing, we are not seeing a big increase in productivity for the high-skilled workers with a lot of experience. And I think that is the challenge, I think, going forward, because we really want to make sure that AI is going to push this frontier outwards for everyone across a range of different tasks, rather than just evening out some of that jagged frontier that we had before. And as I said, the evidence right now is a little bit mixed because we are seeing the penetration of AI in different jobs, in different sectors and different areas of occupation as being relatively uneven. There's a higher sort of penetration in jobs that require more education. We don't know yet what the impact is going to be on work that requires more manual labor, and it's different kind of technologies that are they're going to be employed in that sector. So a lot of questions still in terms of what the impact is likely to be. So let's take a step back now, or maybe a step forward, and think about the opportunities and costs for California. And I'm someone that's moved back and forth between the East Coast and the West Coast, and I definitely concluded that California is the best place to be. So I might be a little bit biased here in terms of where I think the opportunities are. But it's certainly, I think we know that when it comes to technological innovation, geography does matter. And in particular, if we look at the agglomeration effects of locations in, since 1976 from a paper by my former colleague at Stanford, Nick Bloom. It is certainly not the case that innovation just happens randomly across geography. Innovation tends to be concentrated, and if we look over the last few decades, 3 out of like the top 5 locations where innovation really happened in technology have been in California. And that is important not only for the locations themselves, but also I think for the state overall, because one of the things that we've seen as far as the diffusion of jobs related to technology, it tends to spread out, but it tends to spread out in areas that are still relative nearby to the innovation hubs. So if we look at like technological innovation since the 70s, it may happen in the hubs around like SoCal and NorCal, and then as we look, so 5 years, 10 years, 20 years, 30 years since the introduction, what we see is that the jobs are going to spread out in adjacent areas. So it's not the case that only the Bay Area is going to benefit from these new technological developments. There are benefits that are going to happen across the state. And I don't think there's particular reason to believe that this is not going to happen in this technological transition as well. But I think, as we're all aware, even though we are in a position where, as far as employment is concerned, we do have a significant advantage in terms of the number of employers in California, and both those are number of firms that are operating in California, and also the number of employers. And the number of workers, we do face competition. And I think that is, from a policy perspective, it is important to keep in mind. There are other hubs, and there are other issues that don't necessarily relate to technological progress as such that that influence these choices. So housing, for example, is of course a concern in California. So I feel like we need to actually be concerned about this because, again, things have changed since COVID, and we are seeing, I wouldn't necessarily call it an exodus yet, but we are seeing people moving to other parts of the country. We are seeing startups in technology that are happening in other areas. And so, areas like, Denver and Miami, they're kind of growing, while areas like San Francisco, LA, San Jose are actually sort of like losing people in this space. And I certainly would say that ought to be a priority in terms of policies going forward. So what might be some of the limits, I think, in terms of AI? And here I think the question of scale is very, 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 very central, I think, to the way I tend to think about where the near future is going to lie. If we look at the AI adoption right now, it is still highly concentrated in large firms. And I think one of the questions is, how are we going to be able to take advantage of AI across the entire range of companies, and how do we enable the adoption of AI in smaller businesses? And there's also a fundamental scientific question, which is it possible for smaller companies to fully benefit from the impact of AI, and also, are they able to innovate and contribute to the development of AI? So I think the question of who can do AI is key for the next few years, because I certainly don't think it's going to be the case that everyone can do AI. And we need to be able to like have access to, we need to be able to process large amounts of data, and we need to be able to conduct R&D. And personally, I feel that our ability to do so is sort of slipping with every week that goes by, and it becomes much more concentrated in some of the big players in the field. And that actually worries me a lot, especially as a professor, because we are used to a model where innovation happens in universities. Universities are at the very cutting edge of developing like the new technology, and firms adopting and learning from academia what the best thing to do is. And I feel that model is breaking down because we no longer have the ability to actually conduct research on AI in a way, in the same way in which you can do it in a big company. It is, I've been teaching big data now for quite a few years, and I feel every year when I teach, I have to add a qualifier that we are not actually doing big data, we're doing baby big data in a university, because I do not have the data and the resources to emulate the experience of what it is to actually work and develop these technologies in one of big companies. Of course, if we had that as a university, we would no longer be UCI or UC Davis. We would be Google, and that's not actually possible. So I think a lot of economists are wondering what the model ought to be going forward about for building relationships between industry and academia that would enable us to continue to remain at the forefront of innovation and be able to contribute and not silo the innovation and the research within a company that is going to make it very difficult to access to any outside parties, and it's certainly going to make it very hard for regulators to really understand and be able to be in a position to make informed choices over policy when it comes to regulation. So this aspect, I think, worries me a lot, and I put it under the potential costs of AI, and certainly coming from the UC as one of the lead institutions in the world, I think we need to engage with this discussion of how we can continue to stay relevant in this age of AI. The second thing that I feel needs to be emphasized, and it's, I guess, the other thing that keeps me up at night, is energy. And everything that we know about AIs now is these technologies are incredibly energy intensive. So forecasts range at the moment, but certainly the expectation would be that once we go from, say, a standard Google search to a sort of AI-powered Google search, the energy demand is going to increase several-fold. Whether it's like 5-fold or whether it's like 10-fold, it's certainly going to be huge. And the moment that happens, we're going to get into this issue of sort of conflicting policy goals. We are certainly trying to move away from an economy that relies on fossil fuels. We need to decarbonize the economy, move away from gas to electricity, which is going to require a lot more electricity, a lot more power than we have today. And on top of that, we are now looking down this corridor where we think our future is going to lie, and at the end of the tunnel is going to be a much more energy-intensive economy than we have today. And imagine now that all of us are going to start using AI in some form or fashion in our day-to-day work, in our studies. I think the energy demand is going to be a really, really significant factor that we need to address going forward. And I don't know whether we kind of have a framework yet to actually think about it. So I know we're a little bit out of time, so I'm just going to thank you before we open it up for questions. And absolutely feel free to reach out to me after this, and I'll be happy to continue the conversation. So thank you.
All right, thank you so much, Dr. Harding, for that talk. We are at the top of the hour, so we are going to go ahead and end. Just a reminder that this recording will actually be on the UCCS website at uccs.ucdavis.edu. And thank you, Dr. Harding, for just a fantastic talk today.
Thank you.